Welcome everyone, my name is Mike Riley, and this is the Deep Space Information Systems SIG meeting. We have our LunarCubes, our Lunar Network SIG. What are we calling this, Abraham?
Either is fine. We interchangeably using that. Go ahead.
This is the LunarCubes Weekly Hangout. Welcome. This is a place where we come and discuss the new lunar renaissance, which is coming up in the next few years. There's a lot of exciting things going on in space exploration and development out towards the moon, and we and this YouTube channel come together to discuss the technologies and the events and the people who are going to make that happen. So we hope that you come back and visit our website and join in the conversation. I'm a co-host for our YouTube channel here, along with Abraham Vassan. Our sponsor is Russell Cox of Flexure Engineering, and I'm very pleased that today we have someone who's going to be talking to us about lunar initiatives, and he is David Dunlop of the National Space Society, and he's been working with Russell Cox and Pamela Clark for a little while now, and we're going to be talking about opening the lunar frontier. So, David, do you have anything you'd like to say? Are you ready to get started?
I'm ready to get started.
All right, so let's go ahead and start a presentation.
Back in 2012, I was attending the meeting of the Lunar Exploration Analysis Group at Goddard Space Center. And I met Russell Cox, and I heard his presentation, which is, I think, the very last one of the meeting. And he talked about starting in International Lunar Geophysical Year. And this was the 60th anniversary of the International Geophysical Year that happened in 1957-58, would be coming in 2017. And so here we are all these years later. 60 years has almost passed, and that was a big success internationally, and there's a trend for many nations now to go back to the moon. So that just struck me like a lightning bolt, and I thought, gee, that's a very powerful idea, and so I started to work closely with Russell and with Pamela Clark on promoting this idea and trying to develop it. And so that has come through our collaborations into a series of things that we're doing called the Lunar Initiatives, and these are designed to open the lunar frontier. If we look back to 1957-58, of course, Sputnik happened. That was an electrifying thing, and Sputnik was the project of the Soviet Union for the International Geophysical Year at that time, and that started the space age. And then the United States, our investigator, James Van Allen, discovered the radiation belts, and he fired a rocket up from a suspended balloon and discovered that there were the radiation belts now bearing his name. But some 60 nations participated in that International Geophysical Year, and most of the projects concern either the Antarctic or the Arctic. So the idea here is that we can do something similar to bring the world into the opening of the new lunar frontier. And so these are the lunar initiatives that we're participating in. We're also reflecting not just the three of us, but I think this is really a global movement, and we're reflecting a lot of convergent thinking on the part of other countries and other organizations, not just the National Space Society or Flexure Engineering. So I don't think that we're claiming that this is all our stuff, but this is actually more powerful than that. I think we're part of a rapidly emerging global movement, and we hope to accelerate that. So we think that we can use CubeSats to provide an affordable way for many more people to come into this enterprise and this campaign. And there are quite a number of existing lunar initiatives that are being made by the major spacefaring nations. And there's also the Google Lunar X Prize. So if we look at some of those, you can see there's quite a list here. China, India, Japan, Korea, Russia, US, and the lunar cubes are certainly an order of magnitude or less expensive. So that opens the door to many other players. Many other people can join this and be involved. And that's revolutionary. And so I think that we're going to see a rapid increase in the number of ideas and the thinking associated with that. And at the present time, there are probably 15 to 20 major missions here, if you just count them up. And then we have the Google Lunar X Prize, and I've listed not all the teams, but the teams that seem to be the most prominent, have the greatest likelihood. They've gotten some recent preliminary milestone awards. So we don't know exactly who will succeed and who will not, but these seem like the best prospects for the Google Lunar X Prize. So if we take a look at all of that, only a small fraction of the G20 nations are involved. So there are about 7 or 8 countries that are sending something to the moon. But we have a lot of rich countries. We have the G20. So we want to make sure that we can get at least all of the G20s and others to participate at this CubeSat level. And that, of course, can complement the larger missions that are already coming along, and can get a lot more people engaged. So what are the lunar initiatives? What are the things that we're looking at? We're looking at conferences, and there have been a number of conferences that have been organized by FlexShare Engineering and Select Investor. So I think we're now on the 4th Lunar Science Applications Conference. In addition to that, there are more focused workshops on CubeSats, lunar cubes, and so I think we're now in our 4th or 5th workshop that's being planned for the middle of October coming up, and that will be happening physically in Mountain View, California. Then, as a result of the conference activities, there are a number of special interest groups that are forming on different aspects of the technology and science and so forth. So some of those special interest groups are probably going to evolve into some lunar special projects. And so if people seem to like an idea and it resonates, and maybe there's some interest in getting some NASA funding or other investors involved in an idea, then it can go from a discussion idea into an actual project development. And part of the larger context is this International Lunar Geophysical Campaign. So there is a big scientific foundation that's been laid by NASA called the League Lunar Roadmap. So they have a whole series of objectives identified in that roadmap. And there's also engineering objectives, strategic knowledge gaps. What are the things that we need to know that we don't know right now in order to move forward? So those lists have been very well developed. There's been lunar decadal surveys with many lunar papers, scientific propositions there, and there's also the fact that NASA has a solar system exploration institute, and that has many international nodes to it. So there's quite a scientific foundation. So we don't need to do that. That's already there, and that's easily available. That's all on the website. We have many people who are well aware of this. There's been European input into that. There's a lunar exploration, International Lunar Exploration Working Group that the European Space Agency has organized, and they've held a number of conferences. So there's a lot of things that are out there that we don't have to reinvent the wheel, and we can move forward in that campaign. One of the other ideas that I think is powerful, would be part of that, is, well, where is this going to take us? And you know, most of the countries have some sort of a geological survey organization. In the United States, we have the U.S. Geological Survey, and that basically identifies what are the resources inside the United States, and they produce a lot of maps so you can find out exactly where there are. And then they also have a lot of studies of the economic potential. So the moon is sitting there. It's a new frontier, and we need to have some sort of an international survey and of the moon's resources. We have a lot of mapping information that's been developed already from LRO and other countries, and that all has to be coordinated on a common geodetic framework. And then there also has to be collaboration on how are we going to invest and how are we going to access these resources. The hottest ticket right now is what about the water? What about the frozen volatiles and the ice that we know is sitting there in the North and South poles? So that's the laundry list of what are the lunar initiatives, and we want to move from where we are right now and encourage small projects and small missions and think that out and develop special projects. But this is part of a larger context, of a larger campaign that will involve many, many nations. And if we have 3 flags on the moon today, you know, there's a Russian flag, and there's an American flag, and there's a Chinese flag, successful landings, why not 33 flags? So I think that's the spirit of the lunar initiatives. So you can see that we've done quite a bit already in the conference and workshops areas. And I mentioned before the upcoming Lunar Cube workshop in October. And so I don't know if I'm getting something popping up on my screen there. So those of you who have a chance to go and register for the Lunar Cube workshop, that's coming up quite soon. There are a number of other presentations that have been made about this International Lunar Geophysical Year campaign. So we've spent quite a bit of time since Russell's initial presentation at a variety of conferences, and I'm going to be going to the International Astronomical Conference in Toronto at the end of this month in early October. So we're trying to move this out into an international forum. Earlier this year, Russell went to London to the European Lunar Symposium and made contact with several of the European countries, and also with Bernard Foyng from the European Space Agency. Ian Crawford, the chair of the conference, was Dr. Mohesh Anand from Open University in the United Kingdom. So the response to this has been very positive. And so this is part of our initiative, is to kind of get the word out, and so we're now pushing to see how we can become more effective in connecting with many other countries. I mentioned the campaign objectives, and there are quite a number of them. So let's go through those. The science and engineering synergies between the Google Lunar X Prize and the science organization. So we have a number of these Google Lunar X Prize teams. We don't know who's going to see it and who will not in terms of winning the prize. But the significant question to me is, what happens when the gold and the glory are gone? You know, there'll be a winner, maybe a couple of winners, I hope. I think that's very likely. And we have 18 teams. And the real gold, in my opinion, is the human capital. And the fact that we've had 18 different groups that have formed, and many of them have developed different ideas about roving or hopping or how to land. And so if only 1 or 2 wins, I think keeping the other people in the game and repurposing them and moving forward and getting to the moon with some scientific goal, there's a lot of potential for doing that at this point. So we've been talking to the Google Lunar X Prize Foundation, the X Prize Foundation, and also to Survey to see if maybe we can get the scientists and the Google Lunar X Prize teams working together. And some have engineering ideas and capabilities, and so the question is, how can we use that for meeting the scientific goals? The International Lunar Campaign roadmap goals and the Survey organization has input into an international coordinating group. That's called the International Space Exploration Working Group. And so NASA sits at the table, and so does Canada, and so are many of the European countries. Most of them are partners in the International Space Station. This is something that we would like to see this International Lunar Campaign become part of that International Space Exploration Working Group. And they have a document which is called the Global Exploration Roadmap. So this is a living document, and we hope to see the elements of the campaign incorporated into the Global Exploration Roadmap. That would show us that we have arrived, that a lot of other people are officially working and acknowledging this coordinated campaign. So that's a major objective, and we've already had some discussions with our NASA representative there, Kathy Larini. And we hope to also have input through other international partners. The Canadians sit there, and the Europeans, as I mentioned earlier. So one of the things that we want to do is to keep track of the new ideas coming up. And when we have the LunarCube workshops and we have the science applications conferences, and Russell and I attended the Interplanetary CubeSat conference. So, you know, we're not the only people that are thinking about this. We see these ideas popping up at other conferences, and we want to try and maintain a list of the ideas and mission proposals, and especially those that get some traction and are moving forward. So we would like to have on our website, you know, kind of a working list of, hey, you know, who's doing what, and you know, what's taking place, what's taking shape as active missions. There are a couple that are being funded already. One is called the Lunar Swirls mission, and NASA Ames and the Koreans have been working on that one. And there's another called Lunar Flashlight that NASA is funding, and that's supposed to go up on the first unmanned test mission flight to the moon with the Senate or the Space Launch System. But as people get funding, then we want to maintain a list so you can, there's a one-stop shopping. So that's one of our objectives, just to make it easier for people to kind of keep track. And as we bounce around and talk to people and are looking at what's going on in this environment, we can make it easier for other people to find out. Now, some of the philosophy of this is also important from an engineering standpoint, because many times an idea will be there technologically, and then it never gets a chance to fly. And if you haven't flown, if you don't have space heritage, then it's not likely that someone's going to take a risk on putting that technology on a mission. People are very risk averse. So the beauty of CubeSats is it doesn't cost that much to test in space. And if you've shown that you can actually do it in space, now you've opened the door for other people to say, hey, I can use that on my mission. It's been proven, it's been demonstrated. And that gap has been known as the kind of the valley of death. You know, there's a technology readiness scale that NASA has and uses. And many of these ideas, you know, they may get to technology readiness 4 or 5. But with a CubeSat, maybe we can test these things affordably, and we can cross that valley of death and actually open the door that will accelerate the level of engineering progress. So that's an important part of this philosophy, and this is not just about science. This is also very much about engineering. So as an engineering company, of course, that's something that Flexure is obviously part of. We want to create a bandwagon effect. That's the next objective, so that other people are thinking and conceptualizing in the same way, and people will talk to each other and start to coordinate, and we will pick up momentum, and we'll get other countries interested. So that's what our presentation schedules internationally are about. We're trying to encourage a lot of people to join this campaign. I've listed here a lot of alphabet soup. There's the Google Lunar X Prize, the Goddard Space Flight Center. That's where Pam is located, Pamela Clark. And we have our International Astronomical Conference. There's an International CubeSat Conference. There's an International Lunar Exploration Working Group that's ESA sponsors. There's an International Space Exploration Working Group with the international space agencies. There are 14 of them involved, including China and India, which are not part of the space station, but they they're invited. The Jet Propulsion Lab, Kennedy Space Center, the Solar System Exploration Research Virtual Institute at NASA Ames, and they have international teams, 7 international nodes. The United Nations has 2 standing committees. The one is the Committee on Space Research, and the other is the Committee on the Peaceful Use of Outer Space. You know, some of the significant companies that have commercial ambitions include MoonX, and I think I've neglected to put Astrobotics, but they should be in that list. There are other foundations that are interested in the security of our ability and access to space. Secure World Foundation and the Space Frontier Foundation also looks at investment. So there are a lot of organizations out there that have a piece of the pie, and getting conversations started, getting other people thinking about what can we do, how can we work together. We want to be a catalyst for that kind of interaction. So, you know, some of the ideas involve international cooperation, and sometimes you need confidence building measures. You know, we're kind of at a low ebb right now with the Russians, and I hope we can get through that. Some of the ideas that we've talked about, like an international sinological survey working group, we have to learn to work together in space, and we need to create some structures. So this is an idea to make proposals, to try things out before we get to the level of having a treaty. And we want to be able to find things that people like, things that people can live with, and so this is a way in this campaign for people to come up and try things out and throw out ideas out on the table. That ultimately will result. That's a very pragmatic way of looking. What kind of legal framework should we then propose? What kind of treaties would be entered into? And you know, we have a space station because we have a space station treaty. So everybody had to agree as to, well, who's going to pay what and how are we going to decide to manage it, and all those things got negotiated out. And so it will be, so it must be with our moon. So some of the things that we proposed in this International Sinological Survey Working Group would be a division that looks at communications and navigation, and we need an infrastructure of satellites to position ourselves in cislunar space. And it's still a challenge. You know, we have small satellites, so we're going to need some relay stations. We're going to need some power, some bigger lasers, some bigger missions that give us that navigation and communication. And a lot of people are thinking about that. NASA headquarters has demonstrated a laser system on the LOTI mission. So there are a lot of ideas about using more inexpensive tracking, using the web to tie together many small dishes that people have at universities or even homes, small organizations, to try and create a less expensive tracking network. So there's some innovations in thinking and going there. The lunar surface exploration, mapping, and resource identification. So as people are putting landers, and we want ground truth, we have a lot of remote sensing information, but we have to go down there and we have to find out, well, how much ice is there really? And are there volatiles that we could tap from pyroclastic deposits that are sitting there as a result of volcanic action? There may be some active lunar vents today. There's a lot of evidence that there are gas releases from the lunar interior. So getting a handle on mapping those resources and the ground truth is a big part of a survey. So we are looking at some of the things that people are doing already, and we want to ask some provocative questions. These are kind of things that should be embarrassing to all of us. But for example, the Lunar Swirls mission that I mentioned earlier has a magnetometer, and they're going to crash a couple of little CubeSats on the lunar surface, and they're going to fly through magnetic anomalies that are on the lunar surface. Well, that's a whole mission devoted to that, and the CubeSats have been designed. Well, we have quite a few missions that are going to orbit the moon and then crash on the moon. So the embarrassing question is, well, everything that's planned to crash, why couldn't they have one of those lunar magnetic the magnetometers? And that's the difference between a single idea and a campaign. So if we can take an idea like this and say, well, gee, why can't other people use the same, why can't we hitchhike on that? And then instead of just learning about one lunar swirl, well, there are a number of areas that have that lunar surface magnetism that we don't understand. We've had a campaign to put a lunar laser retroreflector, and there was actually an agreement to put 8 to 10 of those on the moon, and then the economic collapse occurred. So we ran out of money in Europe and in the United States. And so Doug Curry has been the principal investigator and wants a new network, and he's lost about 40% of the reflective capacities from those reflectors from Apollo, and we need a wider base. So the embarrassing question is, well, we've got a lot of people going to the moon. Why aren't all of them carrying a lunar laser retroreflector? So that's our second embarrassing question. If we're sending things to orbit the moon, well, why can't any orbiter that gets up there become one of those communication relay stations? We have quite a few nations that are going to put up orbiters there, and if we just coordinate our activities without spending a lot more money, maybe we can have that communications network that we all would like to have. So that's the third embarrassing question. So maybe we can embarrass ourselves to be more effective. Well, I don't want to beat this horse to death, but you can see that you know, the specific ideas, the lunar orbital, and this mission that's going to Earth-Moon Lagrange for the Senate launch system, or the space launch system, is going to carry CubeSats, and it's going to be a pretty big deal. It'll have an extended propulsion unit from Europe. So if we've got something that sizable up there in an Earth-Moon Lagrange orbit, why couldn't that be a significant beginning node element? So that's kind of a challenge to our SLS project for NASA people to address, and maybe the Europeans. So that's a hopeful collaboration. And then why can't every lander provide an element of that international long-duration lunar surface network? There were a number of instruments that they wanted in 8 to 10 different locations on. So as long as we know that a lot of people are going, it makes sense to try and see what we can do to work together. Not everybody can do everything. Some of the landers are small, some of them are quite large. But if we put our heads together and we put our shoulders to these objectives, I think a lot more can be done. So that's the value of our campaign, and we should be willing to say, why doesn't the king have any clothes on? We have all these smart people, all these countries spending money, and we have a cheap way to do a lot of things. So let's do more. You know, we can set a higher bar. I've given you a list of special project initiatives. One of the things that's been talked about is a radio telescope calibration beacon, and that might be as small as a 1U CubeSat orbiting out there at L2. There's more that we can do in the area of solar electric propulsion, and so that's another critical aspect. We need precision pointing. We need to have as much ISP as we can. We need long duration stay times. So LunarCube solar electric propulsion is a key pole in the tent. And Russell has, from the beginning, talked about a major initiative to get a lot of people engaged with doing LunarCube work. So there is a proposal that he's been making to have a kind of a mothership going out to Earth-Moon Lagrange, and we could put a lot of LunarCube spacecraft that could be launched from that, and they could chase some of these asteroids, for example. That could be a significant aspect. We could do cycling orbits and look at heliophysics kinds of things with small spacecraft. There's a lot more to be done in that area. There's the problem of a cryogenic power supply, and I'm working with a group right now that thinks that we can develop some small and relatively inexpensive americium lithium generators, and they've been used for decades in the drilling industry, and for drilling for oil and gas, and also looking for radium or for radioactive isotopes for people who are mining and looking at uranium deposits. So there's a lot of operational history, and we think that those might be very suitable. They're things that go down maybe a 1 to 2 inch diameter pipe, and they're no more than about a foot long. So they're exactly the dimensions of a small CubeSat, and they also have the power supply. The power outputs are right in the same range that you would get in a solar array for a 1 or 2U CubeSat. They're from 4 to 15 watts. So there seems to be a nice match, and we're beginning some conversations with Argonne National Labs about that possibility. And so there might be both solar as well as a poor man's RTG using these heritage americium generators. having a plan B, a more structured plan B for a lunar surface network initiative, that's something I think we would like to reactivate and throw into the lunar science community. So in order to do these things, there are special interest groups, of which this is one today. I think we're looking at the communications network, and Mike and Abraham are today's hosts and leading that ongoing discussion. But you can see there's cryogenic applications. We have a very active group along this Florida Space Coast with Bonnie Dubrow, working closely with Kennedy and some of the companies there. And then in the science arena, Pamela Clark is looking at our science payloads and advanced concepts, and also looking at what can be done with lunar analog projects. So that gives you a little view of some of the specifics as we're kind of drilling down to what's involved. Well, this is a lot of, maybe you think, Dave, this is hot air. What are you really going to do? How can we know if this is real or not? And so it's certainly a skeptic's question to say how you're going to evaluate. How will we know if we've succeeded or whether you're succeeding? So this is a list of things that we could see as objectives for a campaign. And this is a pretty conservative one. More than 20 new LunarCube missions will have been launched by 2024. So if our campaign officially begins in 2017, it's going to take people some time to organize and fund and engineer and get stuff launched. So we've used this 2024 date as kind of have we succeeded or not? So we would expect to get at least 20 new projects, and of course we would like to see 50 or 100. So the second thing, we would like to see more G20 nations that will actually have contributed a LunarCube mission. There are only 7 or 8. We'd like to get all 20 and more. We would like to see, as people do more of this, the cost routinely coming down to do a project like this in the single-digit millions. We would like to see a communication network in place. We'd like to see at least a working group for the International Sonological Survey. And we also would like to see this international access to the lunar surface become a routine thing. And companies like Astrobotic and MoonX and others are the means to achieve that particular goal. So we're certainly we want to be cheerleaders for the commercial aspect of this and for the investment community, because that's what's going to make it happen. We want to retire the strategic knowledge gaps so that we have closed those barriers. We want to have, we would like to see an Earth-Moon gateway station. We'd like to see a big project of basically another permanent station at Earth-Moon Lagrange. And so a long-duration facility, and if you look at the global exploration roadmap, they've identified this as a commercial opportunity. So if we'd have another space station out there by the moon, we could do a lot of telerobotics much less expensively than if we actually have to return humans to the surface. And if we can do that, that's a really big deal, creating an Earth-Moon gateway station. And that opens up the ability to utilize fuel that would be coming from the lunar surface and sending things out both back and forth to the moon and also farther out. So we have a lot of successful technology demonstrations to do. And NASA has a technology roadmap. Some of these ideas are part of the things that the NASA roadmap involves, but we're focusing on those that particularly are challenges for LunarCube technology. So we can have a lot of standard, it becomes a pretty routine ho-hum thing where we know how to get there, we know how to do this, it's not that expensive, and it becomes pretty routine. So the demonstrations are extremely important. And that's another funding rationale. NASA wants to spend money developing the roadmap and doing test missions. So we hope to be implementing, their ambitions and those of other countries in that regard. This international lunar network should be up and running, and we should have quite, many of those elements in place. And then the participation at in these kind of missions, we think this should be a commonplace. This should be what people expect to do if they're going to have an advanced degree in planetary science or engineering. Along the way in their career, they should have been part of some sort of LunarCube mission. and that's how they're going to get their feet wet and learn how a space mission really works and put that on their resume. So the last thing is, those are the kind of goals for our lunar initiatives and where we want to start and where we want to end up. And I don't know, I forgot to use the timer. I'm probably over time, but that's the presentation.
That was good.
Any questions?
Thank you very much, David. That presentation was extremely good. And we had covered quite a large basis. So, in terms of your ILGY activity campaign, when do you start seeing results of that? Or like how long is your timetable in mind? You should go as far as 2024, but in terms of your campaign activities, how far are you thinking of going?
Well, our campaign has really been underway since Russell announced that as an idea there at the League meeting. And as you can see on the slides earlier, we've had a number of conferences and workshops. We've had a number of lunar science conferences. We've had many international presentations. We're seeing specific projects ideas. So I mentioned a number of those. Some LunarCube missions have already been funded. The Koreans have announced this Lunar Swirls. That's one of those impactors. That's a Korean mission, and that's exactly, they're a relatively new player, but they're white hot about this. The Korean president told their establishment, "I want you to move up our agenda 2 years." And there's a lunar orbiter, a lunar lander, and the Lunar Swirls mission are now the 3 Korean lunar initiatives. And so if Korea can do it, a lot of other countries can do it. So this is part of the bandwagon. So I'm really delighted to see that. I'm delighted to see that NASA has funded the lunar flashlight. Now Pamela Clark and Bill Farrell and others have looked at another way to measure the lunar ice, and I'm forgetting the name of that particular mission proposal, but it also would fly an infrared spectrometer with a cryogenic, a compact cryogenic cooler, and we want to focus on lunar ice. So I think that's a really terrific idea, and it's right on the roadmap to commercial development. We have some interest from the astronomical community, from the astronomers, and the last hangout we had presentation by the SETI organization, and I believe that the conversations in your group have already indicated the need and the value of a calibration CubeSat. So, I think, if you're looking at these ideas moving into formal proposals with NASA and other countries and commercial investors, the timetable is right now.
Excellent. Like, if you stop sharing the screen, we'll also get to see you.
Okay. Well, I don't know if the people could look at the nice-looking slides rather than my ugly face, but if you want me to do that, I'll try.
Yeah.
If I can figure out how to get rid of my slides.
Just touch this screen share; it will go away. Yeah, there you go.
Okay. So here I am.
Yeah, and we're getting close to the end of the hour. So, any last thoughts and any questions from Michael Riley, and then we will wrap up.
Well, one quick question I have for you, David, is that what's driving all of the new interest in the moon, and is it going to be a flash in the pan, or is it going to be something that has some staying power?
No, I think that we've crossed that threshold already. When you saw the number of major lunar missions that are already being developed, there's a new moon race that's very actively underway, and China, I think, China's landed on the moon. Everybody's taking notice. The Russians had things on paper, but they have 5 missions that they want to put up on the moon. The Indians have been, developing their Chandrayaan-2 mission. So I think most of the other nations see the moon as the test of, making this real. There's an arena of international competition that's driving this geopolitically, but there's also the the luster of, hey, we can get fuel there. We could actually go out and start thinking about making money and using lunar resources. So the investor community is also part of this push, and so we're already moving. And so I think that's to our great advantage. The fact that we have a less expensive way is only going to throw gasoline on this fire. And so I think the prospects are very exciting and they're very positive.
That is very exciting. So Abraham, we're at the top of the hour.
Yes, I think we can wind up and catch up next week hangout. And sorry for the little technology hitch we had in the early part of this hangout.
Well, I think before we go, we should definitely thank David for his presentation and talking about the exciting times that we're in. So thanks a lot, David.
You're quite welcome. Happy to be here, and I'm sorry I overshot my 15-minute window. I had so much to say, and I'm glad I got through it, and I'm sorry I didn't have more time for questions.
Thank you.
Apologize. I'm sure that we can make sure that whoever sees this, if they want to ask questions, we'll have contact information. So just go ahead and contact us, and we'll continue the discussion.
Terrific. Thank you again.
Stopping the broadcast.